All right, so here's just a little example. They don't get easier than this, but it just helps us look at some of the concepts, right? Oh my God. Somebody said, it was funny. I thought it was funny. There's no complaints. You say, oh my God, anytime you want. All right, so here's a graph, and we want to maximize the flow from S to T, right? So everybody study it. How much flow can flow along the top? Everybody buys most 1, right? Most 1 can flow along the top because there's a bottleneck here, right? How much can flow along here? 2. How much can flow along here? Nothing. Nothing, because it's in the wrong direction.
I don't understand why the first one is 1 then.
So why is it 1 here? I mean, just think intuitively. That's your bottleneck, right? You have a little thing here. That's as much water is going to flow, right? So this guy's at capacity. You only can have 1 flow out of this. And because you only can have 1 flow out of it, you can only have 1 flow into it, right? And then that propagates back, right? If no water is going to be created or destroyed, then the amount that flows along this is a constant, which, you raise it up, it's going to be bounded by 1.
So in the case of water, doesn't that flip the other one back? Like, for the amount of water that can't get through? Like, if you have a pipe here that can only accept 1 liter through it for, like, 10 seconds or whatever, and you're trying to send 7 liters, so it's going to send the 6 liters that it's
Exactly, and that's why we're saying we don't like this. This doesn't count, right? How much are we actually flowing along here is 1, right? And how much is flowing along here is 2 because of that bottleneck, and that's in the wrong direction. So sending this way would be dumb, so don't send anything that way. Yeah, in their kitchen? Basement, yeah. All right, so here, what's the total flow, right? Right, this is just, we're flowing 1 up here, we're flowing 2 down here, we're flowing nothing down here. Why is this circled? It's just telling us that we have a flow of 2 with a capacity of 5, right? It was just a reminder of that. And so what's our max flow? Our max flow is 1 plus 2 is 3. Yeah?
Wouldn't you have negative flow at 1?
Yeah, but that would hurt us. We want max flow, so having things come back. Remember, the flow that we is what's flowing out minus what flows back. So if stuff's coming back, it's going to hurt us. And so if we want to get as much water from S to T, then don't use this. You have a choice of not using it. Yeah, so here we're putting 0 flow through this one, right? So this is, everybody see we got 1 through here, we got 2 through here, we got nothing through here, right? And so why can't we push more flow? Because that's at capacity, right? And that's at capacity, and that's going in the wrong direction, right? So later we're going to define another concept called a cut. In fact, the game here is max flow, min cut, if you haven't heard those words. Is that time?
2 minutes.
Excellent. So here's the min cut is how do you cut the things so that the minimum edge is going this way. And that's 1 and that's 2. They're bottlenecks. Here it's not counted. So the value of the cut is 3, and max flow equals min cut, and we're ready to go home.